Hello friends, welcome back to my channel. I hope you are doing well and having a good time studying or doing your analysis. It's summer break though and you may be on vacation. However, I think it's nice to have a source of thesis analysis when you're back. Today we're going to continue the very first steps of statistical analysis for thesis writing series. In the first episode, we talked about the research question, what measurements are important, define variables, and identify each belong to what variable types. We had 3 example research projects for this matter. Then, in the second episode, we started to assess our datasets, got a summary of them, checked missing values, and did the cleaning part. Here is the link to the playlist of the series. Every episode will be added there. In today's episode, we're going to learn the rest of the EDA and hopefully find best appropriate statistical tests. Okay, let's get started. EDA is the process of understanding your data before applying any statistical model. We use EDA to understand patterns in data, detect a structure before modeling, and checking relationships between variables. We already did the first 2 ones in the previous episode, episode 2, so we only stick to the last one, checking relationships between variables. I'm going to go ahead and run this code that we already did before. I'm doing this because I restart and reopen our studio every time that I record a new video, but you can skip this part. So let's start to run the correlation function for the psychology dataset, and it'll give us the correlation matrix that includes all variables. And here's the result. We can clearly see a strong negative relationship, almost negative 0.72, between imposter syndrome and research confidence. This literally says that as imposter syndrome increases, research confidence tends to decrease. And we also see a moderate positive relationship, 0.54, between research confidence and GPA, which may suggest that students who feel more confident tend to perform better academically. However, study hours show almost no or a weak relationship between GPA or imposter syndrome. See 0.08 and 0.01 here. This is an important finding because it shows that simply studying more does not always explain performance or confidence. Now let's move on to the health dataset. Run these initial analysis codes again, and now correlation. We don't include sex, smoking status, and physical activity because they are factors and categorical. So run it. You see there is no significant relationship between variables because they are all less than 0.5. And you might say there is a positive correlation between hypertension and age, but as you can see, it's not that strong. Next, we're looking at the environmental dataset. Run all of these codes down to correlation and run the correlation. Here's the result. Looking at the matrix, you see most variables show weak relationship except one important pattern. Traffic volume has a strong positive relationship with PM 2.5 levels. As you can see, 0.72. This says that areas with higher traffic tend to have higher air pollution. Right? It's not unexpected. The next one that deserves not to be ignored is negative 0.34, which is for wind speed. It says that wind speed shows a moderate negative relationship with PM 2.5. That's not shocking at all. So from these 2 examples, we see that unlike psychology, where we saw stronger relationships, health didn't show a strong correlation except hypertension and age. And also, environmental variables are more complex and often influenced by multiple interacting factors. Now that we understood the structure and relationships in our data, the next step is to find out what tests best suit them. First, let's see the rules that lead us to choose tests. First step, you should always ask, what is your outcome variable? What type of variables are we trying to explain or predict? For simpler datasets, we might say If the outcome variable is continuous, then we use regression. If binary, we use logistic regression. And if categorical groups, we can use t-test or ANOVA. But for our examples, for the first one, the psychology dataset, outcome variable GPA is continuous, the mediator variable research confidence is continuous, and the predictor imposter syndrome is also continuous. So all the main variables are continuous. However, since we are not comparing groups, we are studying relationships between psychological traits and performance. We don't use those tests. We cannot use simple linear regression or logistic regression or just categorical group comparison tests. In this kind of situations, the suitable models would be multiple regression or mediation. But again, here, since the research confidence work as a mediator and not just as a predictor, we cannot use multiple regression, and we only remain with mediation. We choose mediation because we are examining whether the effect of imposter syndrome on GPA passes through a third variable, the mediator, which is research confidence. So multiple regression would be misleading or wrong. In the health dataset, the outcome variable, hypertension, is binary, meaning that it has two categories, presence or absence of hypertension. So because of that, we use logistic regression, which is designed for binary outcomes. And finally, for the environmental dataset, in this dataset, our outcome variable, PM2.5, is continuous, and we have multiple predictors such as temperature, humidity, wind speed, rainfall, and traffic volume. So we chose multiple regression because we want to understand how these variables jointly influence air pollution. And that was it. In this episode, we completed the EDA process from the previous episode. In episode 2, we learned the data cleaning and first part of EDA. In episode 1, we understood the research questions and defined variables based on it. Therefore, based on research question, research goal, variables nature and types, the structure of data, and finally the relationships, we decided what statistical tests to use for each one of them. So it wasn't a one-step, one-aspect decision. We went through all those steps to finally choose what test best suits our data. In the next episode, we will go one step further and start checking statistical assumptions and running our first models in R. This is where theory becomes real analysis. I hope you liked this one. If you did, please like and subscribe to my channel for upcoming episodes. As always, thanks for watching, and I'll see you in the next one.